Okay, let's take a look at another example where we are asked to solve for x. And what we have here is a rational expression. So we have two fractions that equal to each other. So I'm going to show you two different ways of solving a problem like this. The first way of solving a problem that involves two fractions that are equal to each other is to simply cross multiply. Okay, so what I can do is cross multiply, which means to multiply the numerator by the denominator on the other side of the equal sign. So when I cross multiply like that, what I end up having on the left hand side is I have 3x times 9, and on the right hand side I have 2 times 5. Okay? And then now we just simplify this. So 9 times 3x, well, that's just 27x. 2 times 5 is 10. So now I have 27 times x equals 10. And my last step to get x by itself is to use the inverse operation of being multiplied by 27. So the inverse of multiplying by 27 is to divide by 27. Whatever I do to one side, I got to make sure I do the same thing to the other side. So I'm left with x is equal to 10 over 27 on the left. Or if you want to convert that to a decimal, you can convert to a decimal. It doesn't terminate nicely, so we'll have to round. And if we round to 2 decimal places, it gives us approximately 0.37. Okay, so that's how you would solve this problem by cross multiplying. The other way of solving this problem, let me just rewrite the problem here. 3 halves x equals 5 ninths, okay, is to use the inverse of a fraction, to use the reciprocal, okay? But what you're going to find out is when you multiply a fraction by its reciprocal, what you're doing is you're making the fraction equal to 1, and so in a sense you are using inverse operations to solve this equation, okay? So let's start with the left-hand side. I want to solve for x. I want to isolate this equation and get x by itself on the left. So I don't want 3 halves x. I want 1x. I just want x, okay? So to do that, I have to undo 3 halves. So to undo that, its inverse is to multiply it by its reciprocal. So 3 halves, its reciprocal is 2/3. So what happens when we multiply this fraction by its inverse is 2 over 2 cancels and 3 over 3 cancels. So I'm left with 1 times 1 is equal to 1 on the numerator, and 1 times 1 is equal to 1 in the denominator. So I just have 1, and 1x, we're left with just x, okay? But again, 1x is the same thing as just x. But because this is an equation, if I multiply the left-hand side by 2/3, I got to make sure I multiply the right-hand side by 2/3 as well. Otherwise, I don't have a balanced equation. And so notice what happens. We get 5 times 2, which is 10, and 9 times 3, which is 27. And notice it's the same exact thing as what we got here, okay? All right, so that's another way of approaching this problem. Let's work out the next example in another video.